WebSocket clients. So the lecture question today, oh, it's Mike. So lecture question today is similar to the lecture question on Monday, except now your server is going to send some information back to the client. You're not going to, even though today's lecture is about clients, you're not going to write any client code for the lecture question, but write server code that will communicate to a client. So this one, a simple echo server. It's, if you look up any socket.io libraries or any socket, TCP socket libraries, any network communication, this is the standard first example that they always show you. It's the one that they often walk through for any first example, any documentation. They just set up a server that when it receives a message, it just sends that message back to the client. So we'll set this one up, receive a message of type send back containing some string, and then send that same string back as a message of type echo. So last time we set up a socket server, and all that server did was listen for messages and then react to those messages accordingly, just doing whatever it needed to do, which was pretty much just printing them to the screen. We didn't add much functionality. That's what the next 3 lectures are for. But let's look at the other side of this connection now. How do we set up a client, a WebSocket client, that's going to connect to these sockets? So looking back at our picture, we're going to fill in 2 more boxes of this. We're actually going to complete this picture today. We're going to have every piece of this, and we'll start using this architecture to build some apps, as I mentioned, over the next 3 lectures. So let's fill in these last 2 pieces that we haven't talked about over here. We talked about actor systems, creating actors that run concurrently. We connected to a MySQL database. We set up a WebSocket server on Monday, and now we're going to set up these clients to be able to connect to that server. So let's start with the web front end. So this is the first time we're going to flash back, well, besides lab anyway, flash back to some 115 concepts, that module 3 and 115. Let's talk about those and build a front end that's going to connect to our WebSocket server. And let's jump right into some, not code, but HTML, some markup. So building a WebSocket client, first we need our basic web page. We're going to need some HTML to be able to build the web page for our app. And we're just going to add a couple small elements. We're going to have a very basic GUI here. It's not going to look pretty. It's not going to do very much. But it's going to just fulfill our purposes for this example. So we could add CSS. We could add more elements. We could make this prettier. But we're just going to have a very basic, very basic web app for this. Very basic front end. So the very first thing we need to do is import the library we're going to use. We're using socket.io for all of our WebSocket needs. It reestablishes connections for us, makes those connections seem persistent to us even when the socket's disconnecting and connecting. And it's going to add this idea of a message type to our messages and just avoid working with raw WebSockets, which introduces just a few extra things that we would have to handle that we want to abstract away. So we're going to pull in the library. Socket.io, not exactly sure what the latest version is, but I know 2.2.0 will work with everything we're doing. The latest one should probably work as well. But pulling in this library, add this script into the header, just like we did in 115. Whenever we're using a library, just add it into the head of your HTML, and the browser will read that HTML, read the script tag, follow the URL, download that library, download all the JavaScript for that library, and run it on the in the user's browser. Next, we want to add some elements. We've done this before. You've done this in 199. You've done this in 115. A couple HTML elements. One input. I want the user to be able to type in some text, and I want one button for the user to be able to submit text. I don't have it set up in a form. I'm just writing a custom JavaScript function to be able to handle these inputs. So when the user clicks the button, I'm just going to call a JavaScript function, and that function is going to handle is going to handle the messages that I'm sending. So I'm going to write a little bit of JavaScript, and then finally just a empty div with an ID that's going to display the messages that I get from the server. So very simple stuff. We've done this in 1.15. If you didn't take 1.15 here, take a second to look up some HTML, look up JavaScript and stuff. I recommend W3 Schools. It's kind of the standard recommendation. It's got a very beginner-friendly introduction to web technologies. Check their tutorials out. What HTML tags, properties, elements. I'm going to use those words quite often, so get familiar with that terminology if you're not. If you took 1.15 here, you're good to go, at least in the last few semesters. So with that, the next thing, we want to import our JavaScript code. Now, it's important that we have this at the end of the body, not in the head of our HTML. As soon as a JavaScript file is downloaded, it is ran by the browser. The library doesn't have any code, at least to my knowledge, any code that really needs to be ran at any certain time. When it's ran, it just has a collection of classes and functions and all kinds of functionality, but doesn't do anything when it's first ran. As opposed to our code, just the way I have this page set up, our code is going to run as a script and actually have some functionality to set up the socket connection when it's ran. So we want this at the bottom of the body so that initialization code is ran after the page loads. There are a few different ways we could do this. The simplest is to put it at the bottom of the page. We could also put it in the head and then call a method onLoad on the body. There are other ways to do it, but the details are not important to what we want to do today. This will suffice. Okay. So let's look at the JavaScript. This is where we're really doing things. This is where we're working with the web sockets. HTML is, thinking of the MVC architecture, HTML is just a view. It doesn't do anything, it's just to display content. And then JavaScript is the controller that's really making things happen. So JavaScript, first thing we're going to do is outside of any functions and any other code, if we had classes here, it'd be outside of all the classes. We're going to set up the socket connection. We're going to connect to localhost port 8080. Presumably our server will already be running. And we're going to connect to it, establish that connection, and get a reference to the socket connection that we just opened with the server. So this runs, as soon as this file downloads, it's going to run it as a script. So this executes as soon as the page loads. We don't have to call any extra functions to get this to happen. So now we're connected, and we want to set up two things. You're going to see the pattern whenever we're setting up a WebSocket connection, either client or server. Two things have to be defined. What you're going to do when you receive a message, which we already saw on the server side. That's the server side, what we do when we receive a message. That's the one piece that we've seen already. And server and client, how do we send messages, which will be baked into any code that we write? How do we send messages back to the other side, either client or server? So for a web client in JavaScript, we're going to use this on method. So that reference to the socket that we got from the library, we're going to call its on method, which takes two arguments. A message type is a string. Message types are always strings when we're working with WebSockets. And then, not to be confused with the type of the content of the message, which is, for this class at least, will either be string or nothing. The message type and a function that's going to be called when a message of that type is received. So the socket.on message type, whenever I receive a message of type ACK, for acknowledgement, execute this function, and then the function will take one parameter, which will be the content of that message, if there is any. So if this message has some information attached to it, it will be in this parameter, which is whatever we want to name it. I happen to name it event, but it's just a variable that you get to declare. Then the body of the function is just whatever you want to happen when you receive a message of that type. So here we have two different types of messages. The two, not to be confused with the type defined by the string, but two different kinds of messages that we're going to receive. We have ACK, which for this setup, we'll look at the server-side code and I'll show it all running in IntelliJ towards the end of lecture. But we're going to receive this ACK message, which is going to receive some string from the server. So this is going to contain a string as its message. And that string is going to be in this event variable. And for our purposes here, I'm just going to display that on the screen. I'm going to add that to the web page to show it to the user. I'm going to add it to this display message, that empty div that we had. And it's going to add whatever I got from the server to that div. So the user can see that something happened. We got a message from the server. I'm just going to display it to the user. Of course, we'll add more functionality. Those will be JSON strings eventually. This is how we're going to get a JSON string from the server and then render it to the web front end. So like for demo 2, if you're doing web, you're going to have something like this, socket.on, whatever message type you decide to name that message. Game state is what I often use for those purposes. I'm getting that JSON string from the server, and then I'm going to render it, parse the JSON, and display all those elements onto the GUI in the browser so the user can see what's going on. For this, I just want to get it in, just display it all. But this is where those JSON strings are coming from. And for demo 2, you're just making up your own JSON strings and calling functions with those made up JSON strings. But eventually for demo 3, you're going to set up the socket server, and those JSON strings will end up coming from the server. For demo 3, you'll have something similar to this. And then all of this function here will be your function that you're writing for demo 2. You're just going to say, when I get this message, call my function, that'll update the GUI, and everything will run. So we're starting to see things, this week and next week, we should see things starting to come together. The whole architecture of the vision should start becoming apparent there. Anyway, so ACK takes in a string. So event is a string in this case, or at least it should be if the server is set up properly. And then we can handle that string however we want. So this is similar to a case class when we're talking about actors. I get a case class. That case class has some variable contained in it. In this case, it would just be a string, and we can work with that information that we get. We have a second message type here, server stopped. This won't contain any message from the server. It won't contain any information. For our server-side stuff, it would be similar to extending a listener of type nothing. It doesn't take any more information. Or in the actor world, this is similar to accepting a case object and just doing something based on that message being received without having to look at without that message containing any actual data. We just want to know, hey, this event occurred, and then our code does whatever it does when that event occurs. We're not looking at any extra information surrounding that event. And finally, if we want to send a message, the emit method. So we go to our socket, wherever we stored it. I'm storing it in a variable named socket, so it's just socket.emit. But wherever you stored this reference, whatever variable name you used here, call the emit method on that socket and give it one or two arguments. The first argument is going to be the message type as a string. Those message types are going to be consistent throughout every WebSocket thing that we're doing here because we're using the socket IO library, and that feature is a part of that library. So send the message type, and then optionally the message attached to that, to what you're sending to the server. So here I want to send a message of type chat message, and I want to attach some text to that. So I'm going to send some text to the server, and the server should have a listener that's expecting messages of type chat message, and then a listener that accepts strings and then handles that data as a string on the server side. If I don't have a second argument here and I just send the message type, the library will know what to do with that. It'll say, we're just sending this message with nothing as its actual data, and just say, hey, this event occurred, and tell that to the server. And the server should have a listener of type nothing on its end, expecting that message without any data attached to it. So the socket.emit, or rather the .emit method, socket just happens to be what I name a variable, but the emit method, that's what we're going to use whenever we want to send data from the client to the server. The emit method does it all for us. So not much syntax to learn. You can use anything you know about in-browser JavaScript coding, anything you want to do. If you want to have a map with pins in it, like we did in 115, you can still do that stuff, and then when the user clicks on the map, maybe you want to call emit and send that event over to the server, tell the server, hey, my user just clicked on this part of the map or whatever at these GPS coordinates, or this lat long. Maybe you want to tell that to the server, and the server can do something based on that, whatever you want to do on that. But you can add these emit calls after your connection to send information to the server whenever you'd like. Similar to making an AJAX call, though a lot more compact, and you can do it over that persistent connection so the server can remember who you are a lot easier. Okay, any questions on the website? Mm-hmm. Yeah, so event, yeah, we're not using it because there's no information attached to a message of this type, so we don't really have to have event there. I think when we jump to the code, if I remember, I'll try to omit it. I think we can delete that and it'll still work. Depends how the library is built. But we typically, I just have that there because it will take the event. The event just happens to have no information in it for this. The server, just the way the server's set up, it's not going to send any information with that, with messages if type stops, server stopped. Okay, let's jump back to Scala. So we want to do the same thing in Scala. I don't have anything else to say there. We just want to do the same thing in Scala. So we're going to pull in the Java, version of the socket.io client library. We're of course going to use it in Scala, but this library, and this isn't really a point I've pushed very much, or rather at all, this semester. But Scala, since it compiles down to the JVM, to Java bytecode, we can intermix Scala and Java at our leisure. So this library is actually written completely in Java. There's no Scala in this library at all. But since it's compiled into jar files in Java bytecode, we can just import that library and use it. We can use any Java library. We talked about this briefly when we talked about JavaFX running underneath ScalaFX, that ScalaFX is kind of a wrapper for JavaFX. We're actually running a lot of Java code when we use ScalaFX. We're doing a similar thing here, except this socket.io library is just a Java library. So there's one case where that's going to come up, where it's going to be apparent that it's a Java library, and we'll talk about that. But I don't want to go on too much of a tangent here. But the point being, you can intermix Java and Scala code. They can work together. They play really nice together. So we have a new library. We're going to add it to our POM. Run Maven. This is included in the examples repo in Lab 5 in, I believe, the clicker handout code, the clicker standard starter code. It's in a lot of the POMs, so you can just grab it from there. I do encourage you, if you haven't yet, I do encourage you to go to Maven Central and find some POM dependencies on your own. Find a library that we haven't talked about in class and just kind of explore a little bit. It's really powerful how much free code is out there that you have access to. I believe there's millions of libraries in Maven Central hosted, freely available to you. I highly encourage you, if some side project or anything, highly encourage you to go find a library. Think of something like, it'd be cool if I had a library that did this, and just search for it. more often than not, there's a library, unless it's something really crazy. More often than not, there's a library out there for you. So we're going to pull in yet another library for this class, the Socket.io client library written in Java. We're going to use it for our Scala WebSocket clients. So once we import, we're going to import all of the necessary files. If you get errors on your imports, of course, that should be your clue to run Maven, get your pom.xml updated and everything. So we're going to import any necessary code from our library. We're going to use io.socket with the host URL, very similar to what we did on the web client. That's going to return a reference to the socket that was created by the library connecting to that server, or not, or referencing that server at this point. And then when we call .connect on that reference, we call its connect method, that's going to finally establish that connection with the server, get us connected, so we can start having this two-way communication with our server. This setup, dare I even say design pattern, but this setup should be looking very familiar to you by now. We're going to say, we're going to call the on method of the socket and say, hey socket, when you receive a message of this type, run this code. This has to be something that extends Emitter.Listener, which has to implement a call method that takes an array-ish of objects as a parameter and returns unit. So we need this method implemented through this, I believe, interface in this instance, because it's Java code, and then implement that one method, that call method. So this idea of we have to give this a class that extends some type, that implements some method, that structure should look familiar to you. Also, on some message type, do something, that structure should be looking familiar to you as well. So the new thing that we definitely have to talk about is this object star. So this is where it's becoming apparent that this is a Java library. Object star, or object ellipses in Java, this is a Java class, and the star indicates that we're taking in some unknown number of references of this type. So we're going to take some unknown number of objects, and they're going to be stuffed into an array-like object. The actual implementation is dependent on Scala versions and compiler versions and other things, but it's going to implement the array interface, which is going to include the things like the apply method, which says, give me the value at index whatever. So here I'm just saying, give me the value at index 0, and the object class in Scala, which is similar to any ref in, the object type in Java is similar to any ref in Scala, and they both have the toString method as part of their interface, as part of their API. So we have the toString method, so we're going to say, give me the first element and call toString. Now in this class, whenever we're sending WebSocket messages, we either have no information attached to that, we'll stick to this protocol, no message attached to it, no content attached to the message, or one piece of content and it's going to be a string. So when we're working with it like this, we can take advantage of the fact that every object has a toString, and we either get the first object or there's no information to get at all, and we just don't even bother with these objects at all. So either we're doing objects.applyOf0.toString to get the message as a string, or we're not touching the objects at all if it's something a message that contains no information, similar to a case object when we're dealing with actors. So once we get this, we can get away from this object star, get to something we're more familiar with, a string, and then we can do whatever we want there. For the sake of example, I'm just printing it to the screen, but this is where we would be parsing JSON, we would be doing whatever we need to do with the information that we just got, that we just received over this WebSocket. And finally, the easier side, sending a message. We have the emit method with the same exact syntax as we had on the web side, on the JavaScript side. So we're going to call the emit method with message type, and then optionally the message that we want to send, the data that we want to attach to that message. If we just say emit chat message, we would send a message with no information. If we give this a second argument, we're going to send it some actual value. And then, I have a slide. I think I might have misordered it. Or maybe I deleted it. I don't know. Anyway, that last line, socket.close, it's always best practice to close everything gracefully, just like we did for the server, the WebSocket server. To call close, make sure it can clean up anything it needs to clean up, talk to the OS to free up any resources that it's using. If we call the close method, it's just always good practice to remember to do this. And for file I/O, we hid that last semester. And this semester, the libraries, the methods that we call to open files, automatically close the files for us. So we don't have to worry about that. But in other languages, you have to close your files as well. Whenever you're interacting with anything outside of your program, you should be shutting things down gracefully. And if you don't, I won't get mad at you or anything, but it's always good practice. One more thing where we're going to get in some trouble where we can easily get stuck is, what if we want a WebSocket client connecting to a server, and when I receive a message from the server, I want to update my GUI. So this is, of course, something that we're all going to have to do. It'll be in demo 3 of the project. For demo 2, you're just calling your method manually with some made-up JSON string. But for phase 3 or demo 3, you're going to have to interact with your GUI through your WebSockets, through your listeners and your WebSockets. The problem is this WebSocket is actually running on a different thread than your GUI. So the ScalaFX, JavaFX, that library, is the way it handles its concurrency. We mentioned that it is concurrent, but it's not using actors. The way it handles its concurrency is through multi-threading. So there's a new thread that's spun up to run your GUI, and then the rest of your code runs outside of that thread. So when I'm outside of that thread, which I will be when I'm in my listener, in my WebSocket client code, I have to be able to interact with that thread that has my GUI so I can update those GUI elements. Luckily, the library gives us a way to do this. If we call this platform.runLater method that kind of takes a function, we'll get into that on the next slide. We're going to give this some code, and that code is going to be run concurrently, but on the ScalaFX thread. That thread that's running your GUI is going to be ran over there, which means it has access to all the variables and all your GUI elements that you have for that GUI. If you're not running it on the same thread, threads are basically running two completely separate processes. They have different memory, different stack, different heap. Everything's completely separate for those threads. I shouldn't say completely, but mostly separate for those threads. They don't share any memory. So when we run code and we want to be able to jump over here to the GUI, we tell our program, we tell the JVM, hey, I want to run this code. I don't care when. That's why it's called run later. Just at some point in time, make sure this code runs on this thread that's running my GUI. So we have to have something like this. We have to have this if we want to interact with our GUI. Now I have access to my GUI client and all of its variables. I can access those variables. I can make any changes I want. I can update my GUI based on the information I receive from the WebSocket from the server. Well, let's talk about this syntax a little bit. It's something I've been putting off because I want to make sure that we understand inheritance. I really want to hammer that home. But if you're at the point where you want to start using a little bit of shorthand instead of creating new classes for everything, this can be helpful. I, at the very least, recommend it for platform.runLater because the interface just gets tedious doing inside into their class and everything. Anyway, let's talk about this. So platform.runLater takes an object of type Runnable. So now we can do this the same way we've been doing this whenever else we have this need. We can create a new class, extend Runnable, implement the run method, which takes no parameters and returns unit. Technically, it's a Java object, so it returns void, but unit in Scala. And implement that method, create a new instance of that class, and then give that to our run later, call. Now we can do that, and that's how we've been doing this for our buttons on our GUI. That's how we've been doing it for all of our WebSocket stuff, client and server. We've been seeing that a lot, and I've been doing that to make sure that we really see what's happening, that this is extending an emitter listener. This interface has a method that's undefined that we have to override and implement to be able to give this the functionality, and then create a new instance of this, and then give it to whatever class that we want. Scala offers a shorthand for this. What's highlighted now in this run later is doing all of that. It's extending Runnable, implementing run with this method. But the shorthand Scala gives us is it says, whenever you need an instance of an interface or a trait in Scala, interface in this case because it's Java code, whenever you implement a trait or interface that only has one method that needs to be defined, Scala says, just give me an anonymous method, or anonymous function rather, meaning we don't name it, we don't store it in a variable at all. Just give me the function definition that you're going to use for that implementation, and Scala will take care of all the rest. It'll hide all the details of extending the interface and implementing the method and the override and all that. It just says, give me a method, make sure the parameters and return type match exactly what's expected, and Scala just figures it out for us. So here I'm giving it the run later method, a function that takes no parameters and has a body, and this body will return unit. It'll be able to figure that out. If my last line is an int, resolves to an int or something, it'll figure out that it should be unit in this case, because run later expects a runnable. It'll look at that interface. It'll do all those checks. The compiler will do those checks for us. But since I give this the method, the function that matches the method that needs to be implemented from the extension, from the inheritance, with the polymorphism and all that, Scala will just say, okay, you're good. You gave me the information that I needed. I'll take that and run with it. So if you prefer, you can use this syntax. Some of you probably have been using this already. For example, instead of server stopped extending emitter.listener only has one method to define. So down here, I can just give this a function, an anonymous function that takes an array of objects and returns unit. And Scala will extend emitter.listener and implement the method for me with that function definition. So a bit of shorthand. I at least recommend it here because if not, we would have two separate classes just to get one piece of functionality. It'd be a bit of a pain. But yeah, I think it's time we can mention that syntax, start getting some more fancy Scala syntax out there. All right, let's jump back to the server just for one slide to fill in that last piece that we're missing. Luckily, it's a pretty easy piece to fill in, is sending a message from the server to a client. We're going to take the reference to the socket of the client that we want to send it to. If we're inside our listener, we have access to that reference right here, and we can just say send this back to the sender, similar to with actors, where we would say sender as a function, send whatever message to return a message to the sender. We can do the same thing here, just different syntax. Take the socket. The only difference between the client and the server, this is a different library, so just a little bit different syntax. We're going to use sendEvent instead of emit. The only difference is sendEvent has the same functionality as emit, message type, message. So just a little bit different, different method name, but same functionality. So let's see all this in action. And this should, oh, I got some blue here. I neglected to push before last lecture, so I'm gonna make sure I get all my code up here. I don't even remember the last changes that I made. It's not part of today's lecture anyway. Okay, so I have my server, just slightly modified from the server that we saw on Monday. I'm going to react to two different message types. If I receive a chat message of type string, I'm going to print it to the screen just like we were last time, except I'm going to add my sendEvent method. This is where I'm going to send that ACK back to the client. All our clients are set up to be able to receive these messages of type ACK, and then just display the message to the screen. So I'm going to send the ACK, and oh, I got some duplicate stuff here, oops. But just saying that, hey, I received your message, I got the information you're sending. Since I have this duplicated, I should store that in a variable, but oops. So, and then when I get a message of type stop, we're doing the same thing. We're going to stop the server and print a little message. But here we're going to do one thing. I didn't mention this in the slides, but you can get you can broadcast to every single socket that's connected to the server at one time. So you tell the socket server, call this get broadcast operations method, and then call sendEvent on that. Instead of calling it on a single socket, this is going to send that to every socket. So let's run our server. I heard from one of my TAs, one of you was panicking on Monday because this text is red. It's not an error, it's just happens to be red. That's how the library is doing it, how the logger of the library is rendering this text. So everything's fine though. It says socket.io server started on port 8080. We're listening for connections now. So let's start with the web side. Same code that we have in the slides. I just want to open my HTML in a browser. And oh, this is worth mentioning actually. This is the library helping us out. So we notice we have 3 connections made. It's because I have 2 tabs open from earlier today when I was just testing everything out. Now I have a third one, so I have 3 clients connected at the same time. So if I send a message, and Friday we'll see this come together as a full chat app, by the way, in case anybody's wondering where this is going. And I submit, I'm going to get that message back from the server that just says, hey, I got your message. Ideally, we would want this broadcast to everybody. We'll see that next time. We'll see everything come together. But it's just going to say, I received my message. I received your message. And let's take a look at, so there's simple client, but we might as well run this too. Simple client that we saw on the slides just sends hello and then shuts down the socket. Eventually. Sometime. Let's ignore that for now. And then let's see some code. I showed all the idea behind this one, but I didn't show the full text in the slides because there's a decent amount. But I have the same GUI that I had from last time, except I'm adding one text output here as a label, which is another GUI element in the library. So when we just want to display text to a user. I'm going to create this label, and then in my listeners, I'm going to update that label with whatever text I want to show. So let's fire up this GUI. A very little GUI. Let's get Firefox up here. So we have 4 clients all connected to the same server. No, it doesn't want to resize for us. And we can see our GUI, if we send messages here, boom. We can get that message back from the server and display it on our GUI with that run later and all that good stuff that we talked about. So that's communicating over a WebSocket connected to my server. Server's processing that. The Scala server is processing that and sending it back to my client. Same with these web versions. This is a web version. All this is HTML and JavaScript. But when I type in a message, it's sending over the WebSocket to my Scala server that's running Scala code, processing that message, and then sending the message back over that WebSocket to be able to render on the HTML web front end. So now, let's click this Stop Server button, do this last proof of concept. When I click Stop Server, the server stopped, I got that message. When I go to, oh, don't do it to me. The server has stopped. Why did you two not get the message? It always sucks when something doesn't work. But anyway, the server is stopped. I won't get any messages back. The server shut down. Only this, I don't know why, only this one got the message that server was stopped. I might have to look into that. But this is where we can start getting communication across our users, an instant communication. Before we had the polling where we just had we used set interval in the browser and just said, hey, check for updates with an AJAX call every second or so. And then we had to wait a while to get those messages. Now, whenever the server receives a message, it can broadcast that immediately to every single client that's connected. So we can start having these real-time interactions between users. And that's what we'll see on Friday. We'll see a full chat app and see that live interaction between users. So with that, I'll see everyone Friday.